Hi, and thank you everyone for having me. So I will talk about superhuman conversational AI. And over the past decade, we have seen AI reaching superhuman performance across multiple domains. For example, in 2015, AI achieved lower error rate than humans on image recognition tasks. In 2016, DeepMind's AlphaGo um, so shocked the world when it beat Lisa Doll in Go a decade earlier than predicted. And in 2020, AlphaFold 2 solved the protein folding problem, 50 years a long challenge that was considered decades away from being solved. So what about conversational AI? Have we reached superhuman levels in conversational AI as well? So the simple answer is we're not there yet. We don't have yet AI that reach superhuman levels for generic conversational capabilities. However, in this talk, I want to take a more nuanced and optimistic point of view and highlight areas where we are already at superhuman levels, as well as areas which are showing fast and promising progress with breakthroughs year after year. When I say superhuman in this context, I mean one of two things or both. One is performing a top human ability, but at a superhuman scale. For example, being able to read at the level of an expert voice actor, but do that across languages, 24/7, millions in sessions, and so on. And then the second meaning is literally doing things that human can't. In order to do that, I will break up conversational AI to its three main subcomponents: speech recognition, natural language understanding, and speech generation, and show hopefully some fun and inspiring examples from each. I hope you will enjoy and share my excitement. So let's start with speech recognition. For speech recognition, we are already at superhuman levels in some ways. First, just simply being able to listen to spoken language and transcribe, the accuracy of how well an AI does that is measured in a metric that is called word error rate. It means literally how it sounds. And certain models are already below 4% error rate for certain languages. This is an exciting figure because the widely accepted human level is around 4 to 5%. As mentioned in the beginning, speech recognition models operate at superhuman scale, and are used to transcribe, caption, translate, and more in the most popular social and content apps across more than 120 languages. So again, doing that at superhuman scale across languages could cost time. But moreover, recognition goes beyond just simple transcription. It can auto-detect language automatically. It can add punctuation and formatting to the output based on the content. It can also recognize different speakers, filter out background chatter, and more. So let's see some demos that illustrate that. And now it's a bit tricky because I need to mute myself. And yeah, so let's see. So the first example shows how speech recognition combined with language auto-detection, translation, and speech generation can be used as an AI interpreter between two humans that don't have a common language.
Thank you very much for being our first live translate interviewee.
私たちの最初のライブ翻訳インタビューであることに感謝します。
I love seeing what sparks joy in other people's lives. What sparks joy for Marie?
私にとっては一人でも多くの方が片付けを終わらせてときめく人生を送っていただくこと、これが喜びです。
For me, it is a pleasure for as many people as possible to finish cleaning up and lead a thrilling life.
完全な感想ですが、あまりにも完璧に翻訳されているので驚いています。
I'm surprised that it's translated so perfectly.
So packing this capability on a phone gives us humans a superhuman ability to talk with other people in a way that makes the world a smaller and a nicer place. The second demo shows how speech recognition can listen to a specific speaker even when there are multiple loud conversations going on. So let's listen to that one. So what you will see is two speakers talking simultaneously, but each phone is trying to know their own speaker and listen only to that one. So let's listen.
This is my phone. Please remember my voice.
This is my phone. Please remember my voice. I'm having pasta for dinner tonight. I'm having pasta for dinner tonight.
This is me speaking. Please remember my voice.
We'll continue to watch all of this sweep its way through the region, and then behind this front, much cooler air will follow. Ahead of it, still on the warm side. Temperatures right now still sitting in the low 70s, 72.
Yeah, so this is very useful for an AI bar or concert. But again, superhuman ability to separate different based on a specific voice, and of course, it unlocks a set of capabilities. The last example demonstrates the ability to recognize irregular speech, whether that of people with speech disorders, strong accents, or even very young kids or very old people whose speech, volume, and pace are very different than what previous models could support. This is clearly a very important capability for equity and inclusion. So let's listen.
I'm Dmitry Kanievsky.
I am Dmitry Kanievsky.
I'm speech research scientist at Google.
I am speech research scientist at Google.
Before Google, I worked at IBM.
Before Google, I worked at IBM.
Before IBM, I worked in Institute of Higher Mathematics.
Before IBM, I worked in institutes of higher mathematics.
This kind of functionality and the ability to translate their voice to a more standard voice actually allows them to use products like Assistant, and we've seen people with ALS and other great disabilities be able to use that technology for a more normal life. So we've seen how speech recognition achieves top to superhuman levels at superhuman scale, and speech generation doesn't fall behind. Gone are the days of mechanically sounding bots, and today it's very hard to tell generated speech from humans. Let's see if you can. So I have here two examples, each with two recordings saying the same sentence. One is a professional voice actor, and the other one is an artificially generated speech. Let's see if you can tell which is which. So let's do the first sentence and then the second one.
She earned a doctorate in sociology at Columbia University. She earned a doctorate in sociology at Columbia University. George Washington was the first president of the United States. George Washington was the first president of the United States.
So again, both of these utterances, one was a machine and one was a human. I will leave it to you to see if you manage to guess. Maybe if people ask, I will tell at the end. So as before, by the way, this can be done at superhuman scale with hundreds of voices in more than 40 languages. But moreover, AI has the superhuman ability to clone human voices, requiring only 30 minutes of voice recording samples. So here is an example of a voice actor recording, and then the auto-generated voice based on that recording. Yeah, so I think I said like, yeah, so this was this example was of a machine versus human. So now let me, I think I was on mute before. So now what I want to show is the superhuman ability to clone.
According to Science Direct, a flexed posture is characterized by an increased thoracic kyphosis. Contact Center AI brings the best of Google AI to customer service.
So again, the first one was an example of an actor, and then we can actually, using voice cloning, make it say whatever we want. But it's not just about the quality of the voice. It's also about the understanding of the semantics of language in order to achieve reading of text-to-speech levels that are better than the average person. Let's hear some examples of how AI uses context to pronounce correctly identically spelled words, as well as its ability to maintain top level also when we're using it for rare and complex words or even tongue twisters. So let's listen to these.
He thought it was time to present the present. Don't desert me here in the desert. Basilar membrane and otolaryngology are not autocorrelations. Peter Piper picked a peck of pickled peppers. How many pickled peppers did Peter Piper pick? She sells seashells on the seashore. The shells she sells are seashells, I'm sure.
And we can actually make it even say it faster.
She sells seashells on the seashore. The shells she sells are seashells, I'm sure.
So we've seen that speech recognition and generation can perform at top human levels and even beyond. So what about natural language understanding? So while this is the most challenging area for achieving human level, we are encouraged by the recurring breakthroughs that we have had year after year in the past 10 years, and even more so in the last 5 years. So let's do a quick recap of the last decade, but don't worry if you don't understand all the buzzwords, and I will really try to cover the stuff short. So some of you may recall that not too long ago, NLU systems required deep understanding of linguistics. It was a complex and unscalable approach that required large teams of linguists, PhDs, writing grammars, hoping to cover all possible ways a user might express an intent. In 2013, Word2Vec brought AI word embeddings to the mainstream, demonstrating understanding of the semantic of words and the relations between them. And soon after, LSTMs came with improved long-term memory, moving up from words to sentences and even short pieces of text. This actually took NLU applications such as translation to a whole new level. In 2017, the seminal paper, Assistant is All You Need, introduced what is called the transformer architecture. So this allowed for longer-term memory, expanding natural language understanding to paragraphs and articles. But more importantly, these models were multiple of orders magnitude more efficient compared to previous approaches, which meant that you can train now much bigger models on much more data at a much lower cost. So this opened the door for the era of large language models, And as we will see, for language models, actually size makes a huge difference. In the following year, the BERT model was introduced. It was yet another breakthrough in our ability to train very large model. What it provides is a scalable, what we call self-supervised training methods using public data. So this method doesn't require expensive and timely manual work such as labeling. It just teaches itself from the internet. It also demonstrated that a generic large language model that is trained from the internet over a very large corpus of text can then be fine-tuned to specific tasks with relatively very little additional training. Moreover, these generic pre-trained models often outperform smaller expert models that were trained specifically for that task. Finally, in 2020, this opened to large language models and they took the stage. For example, Google introduced Mina. It's a large language model that was exceptionally well at having open domain dialogues with humans. Previous open domain chatbots had a critical flaw. They may have sounded reasonable, but they often didn't make sense. They sometimes said things that are inconsistent with what has been said so far, or lack common sense and basic knowledge about the world. Moreover, chatbots give often responses that are not specific to the current context. The most famous one is, I don't know. And it's a sensible question to any question, it's a sensible answer to any question, but it's not specific. And chatbots do it much more often than people because it covers many plausible inputs. So it's kind of a way to go around, but it doesn't really provide the value. Mina could conduct conversations that were more sensible and specific than the previous state-of-the-art chatbots and rank close to human level in a new metric that was called sensibleness and specificity average, which covers basic but important attributes for human conversations. A year later, a new model called Lambda came to be. It was built on top of the previous ability to generate a human-like dialogues that are grounded not just in fact, but also in hyper-specific context. An intriguing extreme example of this ability was Lambda's ability to role-play any object in the world and stick to that role throughout an open-ended conversation. Here I'll show you two examples of such role-playing in a conversation between Lambda and the human. In the first dialogue, Lambda plays the role of Pluto, planet or not, and in the second one, that of a paper airplane. So let's listen to the dialogues. And again, things about sensibility, context, and ability to hold the character in a way that is grounded in facts.
Let's listen to a conversation the team had with Pluto a few days ago.
I'm so curious about you.
I sense your excitement. Ask me anything.
Tell me what I would see if I visited.
You would get to see a massive canyon, some frozen icebergs, geysers, and some craters.
It sounds beautiful.
I assure you it is worth the trip. However, you need to bring your coat because it gets really cold.
I'll keep that in mind. Hey, I was wondering, have you ever had any visitors?
Yes, I have had some. The most notable was New Horizons, the spacecraft that visited me.
That must have been exciting.
The team that created New Horizons was very excited to see me. I also sent them back a picture of myself since I had not been seen up close before.
That's so great. What else do you wish people knew about you?
I wish people knew that I am not just a random ice ball. I am actually a beautiful planet.
Well, I think you're beautiful.
I am glad to hear that. I don't get the recognition I deserve. Sometimes people refer to me as just a dwarf planet.
Don't let it bother you. You're amazing.
Thank you for the kind words. I appreciate it.
Thanks for talking with me.
Anytime, I am always open for people to chat. I hope you have a great day.
Let's listen to a conversation the team had with Pluto a few days ago.
What's it like being thrown through the air?
It's quite the experience, actually. The wind blowing against you and the trees flying past are quite the sight. You never know where you'll land either.
What's the worst place you've ever landed?
That would have to be in a puddle. I was just barely still intact, so I was stuck there for a few minutes. It was quite annoying.
Oh, that sounds awful. Were you able to fly again?
Thankfully, I was. I had a...
What's it like?
So yeah, so I think this is a quite amazing capability. And this year we saw a very exciting breakthrough with the introduction of PaLM, an incredibly large language model built on new distributed architecture that allows it to scale to 540 billion parameters. For comparison, that this is like 3 times the size of GPT-3. The big jump in size allows the model to succeed in new tasks that are qualitatively different than previous ones, as well as beat the average human on a set of language tasks. Let's see some examples of those new advanced tasks that this model can handle. So the first one is the ability to explain a joke. Understanding humor and puns is considered a high level of intelligence and language understanding. Here, the user is telling the model a joke that uses an uncommon pun, and the model explains why the joke is so funny. It's a bit of a joke killer, but it's great to actually train people who don't understand jokes. So I'll let you, all right, so basically the joke is, did you see that Google just hired an eloquent whale for their TPU team? It showed them how to communicate between 2 different pods. And now the model explains that a pod is a group of whales as well as a group of TPUs, and you mean one and you actually mean the other. It's a very complex pun, but still the model manages to understand it and explain it better than many humans I know. The second one is the ability to articulate a chain of thought. We all know from school that solving a problem is hard, but being able to articulate your chain of thought that led you to the solution requires deeper level of understanding, both on the domain and the language. And here on the right, the model is given a math word problem and is asked to explain its chain of thought leading to the solution, right? So it's being asked, you can see the prompt below, right, on the right side below. The cafeteria had 23 apples. If they used 20 to make lunch and bought 6 more, how many apples do they have? And the model explains the cafeteria had 23 apples originally. They used 20 to make lunch, so they had 23 minus 20, which is 3. They bought 6 more apples. So it really goes through the explanation and not just a copying or whatnot. It shows, again, understanding of both of what we want from it and from the question and the world and how to approach it. Finally, the last example is...
Hi, Yariv.
Yeah.
Sorry to interrupt. We're not able to see the slides.
I am screen sharing. Okay. I can stop sharing and share again?
Yeah.
Let me share again.
Yeah, we can see it. Yeah.
You know? Okay. Yeah. So finally, the last example is the ability to discuss counterfactuals, events that didn't happen but could have happened. And this ability is considered the highest level of causal reasoning and unique to humans. Here we see the model reasoning in that way, right? So basically, what really happened is that the president rides a horse, but we're asking the model what would have happened if that president would have ridden a motorcycle, and the model manages to understand the counterfactual question as well as choose the right answer. So we've seen how over a period of a decade, we progress from hard code grammars to extremely large language models that train without any human guidance and can achieve state-of-the-art performance across dozens of complex NLU tasks, and even outperform the average human on some of these. And they can even explain you a joke that you don't understand. So we're almost at the end, and we've seen examples of superhuman capabilities and superhuman scale. And to conclude, I want to show how all of these come together and provide commercial and user value in a publicly available product. So this is like basically The future is now. Google Duplex is a human-like voice bot that uses conversational AI to automate phone calls that sound, well, human. And Google Duplex was first introduced as a human voice bot that can make reservations in restaurants for you. But since then, it was expanded to more languages and use cases, including doing millions of outbound calls to businesses on behalf of Google to find out the details and opening hours of businesses in a scalable manner. This is the only scalable approach to ensure that Google Search and Maps can provide users the most fresh and accurate information. So let's hear an example of such a conversation. And to be clear, the male voice is a bot. So let me demo.
Townsend Pharmacy, how can I help you?
Hello?
Yes.
Hey, I'm calling from Google Maps. Given the current health situation, I just wanted to update your hours. I'm an automated service, so this call is recorded to improve Google services. Could you please tell me your opening and closing hours throughout the week?
Do you want the hours for the store or the pharmacy?
I was hoping to get the hours for the pharmacy.
Okay, so Monday through Friday is 8:30 to 4 p.m.
Mm-hmm.
And then during the weekend, let me just double check, okay? I know Sundays we are closed.
Okay.
And one moment. You know when we open until Saturday? Okay, so Saturdays it's 9:30 to 1 currently.
Sorry, let me repeat all the hours back. Monday through Friday from 8:30 a.m. to 4 p.m.
Yes.
Saturday from 9:30 a.m. to 1 p.m.
Yes.
Sunday you're closed, is that correct?
Correct.
Okay, got it. Thank you for your time.
All
Goodbye.
right, no problem. Bye-bye.
So, that's quite impressive in my opinion. And just to finish, let's hear just a few more short duplex extracts and the reactions that this technology generates from people.
Hi, I'm an automated system from Google calling to make a reservation for a client.
Hi, I'm calling to let you know that a customer is running late.
Hey, I'm helping shoppers locate a place to buy face masks.
I'm calling from Google Maps. Given the current health situation, I just want to update your business hours.
I'd like to make a women's haircut appointment for a client for Friday the 17th.
I'm calling to cancel a table reservation.
Could I just confirm that I dialed the direct number to reach Buffalo Wild Wings?
Quería confirmar a qué hora abren y cierran hoy.
I'm calling from Google to verify your business name and address.
I was calling to find out your business hours for today.
Today, because it is Saturday, sorry, it is Friday. Sorry, I got my days mixed up. Friday, we open at 8 and close at 8, or open at 6. Well, my days are all off. We'll open at 7 and close at 8.
Okay, got it. Thank you for your time.
Wow, you got it. It's amazing what an automated system can do.
Hey, thank you, Google Assistant. So nice to talk to you.
Awesome. This is so, I feel like I'm in the future.
You're awesome, Google. I love you. You're like the smartest computer I ever talked to. All right, cool. Thanks. Have a good night.
Thanks. You're the best robot I've ever met.
Okay, this is very smart.
You're the most awesome automated person ever. Thank you.
Thank you.
Thank you.
Okay, thank you.
Thank you so much.
Okay, thank you, robot. Your job is...
So thank you for listening. And the title I chose for this talk was intentionally somewhat provocative and optimistic. However, I do hope that you also found it insightful and thought-provoking, and that you share my optimism and excitement about the near future. So thank you so much.